Okay, so let's do the lab that I've shared in UFuture. So we're going to do a multi-protocol BGP. This is just an introduction to how you want to configure the BGP. So according to the diagram, we have three routers, router 1, router 2, and router 3. And connection to router 1 and router 2, there's 1 gigabit Ethernet and two serial interfaces. So meaning to say we can see there are three paths from router 1 to router 2. So we can go through the gigabit Ethernet and also through one of these serials lah. So ada 1, 2, 3 and then daripada router 3 ke router 2. And vice versa lah. Maksudnya daripada router 1 boleh juga ke router 3 melalui 3 bus dan seterusnya. Okay, so let's begin with the configuration. The lab manual bagi specification untuk both IPv4 dan IPv6 untuk tunjukkan dekat you cara nak configure menggunakan address family. But for the demo, I'm going to demo for IPv4 sahaja dahululah for brevity. Okay, so untuk note, setiap router ni by default dia dah enablekan IPv4 unicast routing. Jadi bila kita advertise, sebenarnya dia dah automatically advertise. Okay, saya tunjuk jugalah bagaimana kita nak activate all these commands are already in the lab manual, but let's see how it works before you do it on your own. Okay, so kita start dengan R1 dulu. Let's just configure the IP addresses first, the interfaces, so that we can enable BGP after all the connectivity has been done. So it's very important for the connectivity to be checked before we configure BGP, sebab BGP bergantung kepada kita punya global RIP ataupun the global routing table. So dia mesti ada path ke setiap router, the physical path, sebelum dia ada virtual ataupun the routing protocol path. Let me show the IP address first. I mean the interface first sebab dia tak sama dengan your lab manual. Okay, so we're going to use gigabit Ethernet 2/0. This is according to your own GNS3 lah sepatutnya. Right? Okay. So I've assigned the IP on router 1. Let's assign the IP on router 2. This one has the same interface in gig. There's only one directly connected interface from router 1 to router 2. Let's test a ping. Okay, so success. That means the IP connectivity is already successful. Let me check the interface for router 2 to router 3. So this is through Gigabit Ethernet 3/0. Okay, now let's connect to router 3. Okay. Okay, connectivity from router 2 to router 3 is successful. Now let's do the connectivity from router 3 to router 1. Okay, so let's check the connectivity, whether the interface is correct or not. 5151, this is 5050. So I've wrongly configured the interfaces. So I have to check again. 50 is supposed to be 50.10.1.3.1. Okay, it should be correct. 3.3. Okay, success. So to show IP interface 3. So 1.3 is up. See, it is up. Okay, both is up. So by right, you should be able to ping to router 3. Okay, so now all the interfaces are up. Okay, so now that we have verified the connectivity, let's do the multi-protocol BGP. Let's do on router 1 first. Okay, so the way you configure a router is just the same like any other routing protocol, like your IGP. You start with a router keyword and then the name of the protocol and then your AS number. And it's very important for us to determine the router ID. Otherwise, it's going to automatically take the highest loopback IP address, which reminds me, I haven't configured the loopback addresses yet. So I'm going to configure it in a moment. Okay, so the router ID for router 1 is 1.1.1 lah. Okay, si kita configure loopback addresses dulu sebelum kita boleh advertise lah. I forgot to configure. Okay. Okay, 26 is 192. Okay, nanti salah pula. Okay, on router 2. And look back address on router 3. We have all the interfaces configured. Should be like that. So let's get back to the BGP. So in the lecture video, I've already stated that we have to configure neighbor relationships first explicitly. That means we have to configure on our own. So this is different than IGP, such as OSPF and EIGRP. OSPF and EIGRP, dia once kita configure router EIGRP and some other parameters, for example process ID dengan AS number, and if we have hello timer, hold down timer dan sebagainya, area ID to OSPF for example, they will use the multicast address to find other routers yang being configured with OSPF and the same parameters as the local router. So dia akan automatically form neighbor relationship dengan semua other remote routers yang mempunyai configuration routing protocol yang sama. Tetapi untuk BGP, kita kena explicitly bagi tahu siapa yang kita nak jadikan neighbor. Alright? So, the keyword adalah neighbor. And our neighbor lah menggunakan the interface address. Okay, sebab dia akan ambil interface address ini untuk digunakan menggunakan global RIP ataupun the routing table untuk cari kat mana berada router ini. Okay, then the remote AS number. That's why saya cakap kita kena betul-betul make sure the IP connectivity sudah berfungsi dengan baik. So we explicitly tell the BGP to find these neighbors, okay, to form neighbor relationship. Okay, then if you do the lab, you can proceed to do the IPv6 lah. Okay, kemudian nama protokol BGP yang kita sekarang adalah multi protokol BGP. So bila multi protokol itulah kiranya BGP version 4 plus. Okay, dia ada capability untuk configure untuk beberapa jenis connectivity ataupun address family. So sebelum ni kita guna IPv4 sahaja. Okay, so dengan itu kita kena gunakan keyword address family lah. Okay, so kita boleh sebenarnya ada beberapa. Okay, so kalau dalam lecture di Cisco Net Acad, dia akan bagi tahu address family interface dengan sub address family, AFI dan SAFI. So inilah dia, ini AFI, the address family, dan SAFI dia pula katalah IPv4. So the SAFI will be sama ada multicast, VPN, unicast dan sebagainya. So kita ada IPv4 unicast lah untuk demo saya kali ini. So untuk address family IPv4 unicast, sebenarnya BGP sudah terima automatically activation untuk interface yang kita dah declare sebagai neighbor di sini. Okay, tapi for demo purposes, so kita nak proper, kita kena configure lah ataupun kita panggil activate. Okay, so we activate these interfaces. So konsep dia sama macam kita advertise the network lah. Kalau dalam EIGRP kita panggil network. Okay. Okay, so that's being configured for router 1. Let's do for router 2 first. This is supposed to be 500. It's BGP router ID. Okay, so neighbor adalah 10.1.2.1. Remote AS is 1000, right? Let me check. Okay, this one has only 2 connections. 10.2.3.3. Okay, as you can see that connectivity to router 1 has already been up. Okay, so let's just do some show commands first. Okay, before connecting R1 to R3. So we can do all neighbors, okay, for BGP. So here we have for address family IPv4 unicast. So if we have configured for, let's say, IPv6, then you're gonna have all those also listed. Kalau tak, kita akan specify lah. Kita nak tengok yang mana. Okay, so for example, show BGP IPv4. So ini untuk IPv4 sahajalah, since I'm going to do IPv4 sahaja. Tetapi this is a very detailed show command, okay, yang kita boleh guna untuk verify lah. Okay, so the BGP neighbor we can check, the remote AS we can check, the BGP version, the remote router ID, and importantly, it should be established. Okay, so in the video, I've already stated that this is a TCP connection. So kita ada beberapa finite state machine that the BGP process goes through, dan ultimately selepas berjaya, dia akan dalam state established lah. Okay, alright. So antara benda yang kita kena agree upon dalam open send state, okay, so boleh refer balik dekat my video. Open send state tu adalah kita perlu hantar open message from each other. Katalah dari router 1 ke router 2, so they both send open messages. Antara benda yang dia akan hantar adalah capability. So apa capability each router? Ini dia lah. So ini semua kita assume adalah by default settings. Katalah we have more complexity, dan kita ada expertise, kita akan tukar nilai-nilai ini. Jadi they need to be sama. They need to be the same with the remote router untuk dia capai neighbor relationship. Okay. Alright. These are the messages for the BGP yang sudah dihantar. Okay. And then kita ada address tracking. Okay. So, like I said, BGP mesti ada IP connectivity sebelum kita boleh ada BGP neighbor relationship. So, dia check lah the router information base or basically the IP routing table does have a route to this address. So, neighbor relationship tu memang kalau kita ping, sepatutnya dia boleh sampai lah. Okay, so that's some of the things that we can verify menggunakan show BGP neighbors inilah. Okay. Okay, so now let's continue the configuration for router 3. The ES number is 300. Let's configure the router ID. B.B.B. Now let's declare the neighbor. It's 2, right? Router 2 is .2. Okay, so all three are up. Let's activate. Active. Okay. Now, at all the routers, I think I've stopped until the activate portion. Okay, router 2, let me check. Let's activate router 2 first. Check the IP. Port 3. Okay. Okay. So next is router 3. Okay, it's already activated. So the next step is we need to advertise all our prefixes. Okay, before that, just check the routing table. Okay, so now, even though we have done the activation, okay, they have only just formed the neighbor relationship. Okay, so we haven't advertised all our prefixes lah. Okay, so what we need to do now adalah advertise all the available networks that we have. Okay, so format dia a little bit different than EIGRP and OSPF lah. Okay, sebab yang tu kita boleh guna wildcard mask. Okay, I've entered double. Router 2. This is supposed to be a network address. Hmm. So router 3 network is 192.168.3.0. Okay, so I think we've advertised all the loopback addresses. So let's check if we have those addresses. So now barulah dia learn these remote networks. Okay, all the loopback addresses from the remote routers have been learned through BGP, B for BGP. So we see that for network 2.0 is via 1.2.2. Obviously, dia lalu directly to the gigabit Ethernet interface lah. Okay. Untuk 3, dia lalu the first serial interface 1.3.3. Okay, so ini kita akan tengok pula cara macam mana dia decide the best path, okay, nanti. Let's verify also on router 2. By right, they all should have the same entries lah. If they have the available addresses. Okay. So connectivity to router 1 also through BGP, connectivity to router 3 also through BGP on router 3. It's also the same. Okay, the loopback addresses from all the remote routers are learned through the BGP routing protocol. So another command that you could use if the show BGP IPv4 unicast neighbors are too long, so you can use the show BGP IPv4 unicast summary. Okay, so this is just a short entry, a summary entry. Okay, so you can check the router ID, the local AS number, the table version. So every time it updates the BGP local RIP or the local BGP routing table, dia akan increase lah. Okay, version dia. Okay, and you can view the neighbor, the version, the AS number, how many messages received and sent, the table version, the input queue and output queue, that means your memory, and how long this connection has been up or down, and all the prefixes received. Okay, so since we learn two loopback addresses from each remote router, so naturally it's going to be 4 lah. Okay, so I hope you can continue the lab configuration for IPv6 as well as practice the summarization for the IPv6 path. Okay, so that's all for the first portion of BGP configuration.